In last class, we derived the derivation for energy stored in a stretched wire. So that is what we have been got, the potential energy. So the potential energy which is stored in a stretched wire for unit volume, if you have been noticed it, so which is equals to half into modulus of elasticity. So that is what into next strain whole square. So this is the formula we have been got it and we derived it. And there is another formula we have been got. So that is what the potential energy for unit volume. The energy stored in a structured spring is equals to half into stress into strain. So like that, we derived the three formulas. Of course, this is the formula which we derived with the help of a derivation. So complete detailed derivation we have studied for a structured spring or the structured wire. So what is the energy stored in it when it is structured? So that is energy which we used to call it as a potential energy. So for finally the potential energy which we used to represent, which is equals to the amount of work done in a spring or a wire, which is equals to U, which is equals to half into stress into strain into volume. So now that is the volume will come this side, will become energy per unit volume is equals to half into stress into strain. This is what we have derived in our last class, the derivation. So now, if you see that the same derivation, we will do it for even a spring also. So now notice that a spring is equals to, so what will happen if I take a spring? So for example, the same derivation we are going to do. So now spring, let me take the spring is exerting some force, so that the extension of the spring, we will take it as a delta x. There is a elongation of a spring is delta x. So as the spring will stretch downwards, so we all knows that then the restoring force will exert in the upward direction, which is equals to Fr, restoring force, and I will take it as a spring constant is K. So that is what delta x is what I'm taking as a extension. So extension in the spring is delta x. So that the restoring force is Fr and the spring constant is K. So we all know last class we studied that Young's modulus is equals to force into length divided by area into change in length. That is what is the formula we have been done. So from that, what is the force is equals to? Check your last class and tell me what is the F is equals to everybody. Young's modulus into A into delta L divided by L. Is it right, everyone? Please respond, guys.
Yes, sir.
Yes. So now, if you have observed very carefully here, so as we all knows that Young's modulus is equals to stress divided by strain. So that is what we substituted. Stress is equals to F by A and strain is equals to delta L by L. So we used to get this formula. From that I am writing F is equals to Young's modulus into A into delta L divided by L. So we all know spring constant K. And what is the restoring force formula in a spring? Anybody can tell, which we already studied. Restoring force in a spring. What is the formula? Fr is equals to, anybody? Restoring force is equals to spring constant into change in length. That is what delta x. So let me consider this delta x. I'm considering as a delta L. That is what change in length. So that I'll get the restoring force Fr is equals to K into delta L. Any problem for anybody? You can ask me. Understand, brothers? Rudreswa, clear? All of you? So that is what restoring force.
Yes, sir.
So restoring force is equals to force exerting on a spring. That is what Fr is equals to force exerted by it. So if I equate both, so K into delta L, which is equals to, what is F is equals to? Speak everybody. Young's modulus into A into delta L divided by L. Any problem for anybody? You can ask me. Are you clear, everyone?
Yes, sir.
So now delta L and delta L will get cancelled. So from that I will get K is equals to what? Young's modulus into A divided by L. So this is what is the K. So all of you remember this. How we will get it. So now, if you notice it here, we all people knows that energy stored in a structured spring. We already got the formula. Anybody can tell that formula? All of you. So we already knows that formula also. K is equal. What is the energy stored in a spring? Formula. Anyone can tell me? Energy stored in a formula. We already studied, it is in long back, you might be studied. So energy stored in a structured spring. Anyone can tell? If you don't know also, you learn now. So we all knows that energy stored in a spring formula is half into K into delta X whole square. So this is the formula which is stored, the energy stored in a structured spring. So now just now we got it, K is equals to, what is K equals to everybody? Young's modulus into A divided by L. So if I substitute that everybody, so what is everybody? If you notice it, all of you, everyone please respond. What is that? Half into, so what is the K value? K value is what? K value is what, Amma? Young's modulus into A divided by L. So we all knows that this is we can take it as a delta X. I will write it as a delta X square. Can I write as a delta X into delta X? Any problem, Pradosh, Rudreswa? Okay, okay. So now we all knows that delta X I assumed as a delta L. So now if I replace that, 1 delta X is equals to delta L. So half into Young's modulus into A into delta L divided by L. This is equals to something. Anybody can tell? All of you? We have studied just now, which is equals to something. Everybody?
Yeah.
Yes, please. What is that? Respond, Ra. Which is equal to what? Force. That is what?
Yes.
Force into delta X. So this is the formula. Please remember, this is very, very important formula. So when the energy stored in a spring is equals to half into F into delta X. Now, if the spring, as we know, spring and wire both are elastic in nature, both are elastic materials, because what do you mean by elastic in nature? Restoring capacity. Do you remember everybody definitions of elastic nature? Restoring capacity. So as soon as the force applied is stopped, deforming force, they will back to their original position. So as we know, spring and as well as wire both are elastic in nature. So let me take it now. So we all knows that if I substitute it here, delta X is K. So from this formula, all of you observe. So I will write the formula. Energy stored in the spring is equals to half into K value is what, everybody? Young's modulus into A divided by L. And in place of delta X, I will write delta L whole square. Any problem for anybody? Are you clear, Pradosh, Rudreswa? So this is the second formula. This is one of the another formula just I want to teach you, because we can solve any question from this in a 2 different ways. That is the reason. So half into Young's modulus into A divided by L into delta L square. Any problem for anybody? Clear, everybody? Now multiply both numerator and denominator with the L. Multiply L in both numerator and as well as denominator. Write it, everybody. So if I do that one, all of you check it, everybody. So what will happen? I will take 1 by 2 separately. Young's modulus into and this L separately I will take it. L into this one, delta L whole square divided by L into L. L into L what? L into L what? L square. Correct, Amma? So half into Young's modulus into A into L is equals to something. Area into length equals to something. Anybody can tell? Which is equals to what? Please respond. Which is equals to volume into this one I will write as a delta L by L whole square. So we all people knows that delta L by L is equals to something. Anybody can tell? Stress or strain? Strain. So I will write it half into Young's modulus into volume into delta L by L is equals to strain whole square. Is it okay, brothers? Clear? So now I will write a strain.
Yes,
are you saying? So the Young's modulus into volume into, I can write strain square. How I can write, everybody? Strain into strain. So now Young's modulus and strain both together we used to call something. Anybody can tell? Half into volume into Young's modulus into strain, something I can write it into another strain. So we all knows that Young's modulus is equals to stress divided by strain. So now Young's modulus into strain is equal Young's modulus into strain, which is equals to something. What is that, guys? Which is equals to stress. So respond and say involve in the class. That is what. So half into volume into this together I can write as a what? Everybody, stress into strain. So that is only is our formula. So check it, everybody. The energy stored in the spring, which is equals to what? Same formula we got it. Am I right or wrong? Verify it. Stress into strain into volume. So if you want to calculate per unit volume, for energy stored per unit volume is equals to, everybody, half into stress into strain. Any doubt, anybody can ask me. This is the derivation. So in two different ways you can solve this question. So whatever the convenient for you, you can solve it. There is no way, there is no force. So you can learn anything which is convenient for you. Are you clear, everybody? Yes, please.
Sir.
Love you. So whatever you will feel convenient and interesting, you can learn that method. So this is all about energy stored in a spring. I hope you all clear. Any doubt, anybody can ask me, or else we'll solve one question related to that and we'll proceed further. So both methods I will teach you. So you have anything doubt, you can ask me and then we'll proceed. So we'll start, everybody. Are you clear in this? Kadir, Rudreswa, Narayan? Yeah, do it. Any doubt, please let me know. Anya and Samya both are in same meeting or different meeting?
Same meeting, sir.
Okay. Rudresh, clear, Rudresha? Pradosh?
Yeah.
Now, write the question. A rubber cord of length 10 centimeter, a rubber cord of length 10 centimeter is stretched up to 12 centimeters. If cross-sectional area of cord is 1 millimeter square, find the velocity of a missile which is mass is 5 gram. Okay, missile which is hit with this rubber cord. Like imagine like a rubber gun it is. So whose Young's modulus of this rubber? Young's modulus of this rubber, which is equals to 5 into 10 power 8 Newton per meter square. Okay. So option A, 10 meter per second. Option B, 20 meter per second. Option C, 15 by 3 meter per second. Option D, 8 meter per second. So whatever is convenient for you, you can. So just understand the question first and then we'll proceed further. Any doubt, anybody can ask me. So we'll proceed accordingly that. Make it everybody. Understand the question, everyone? Anything doubt, you can ask me. Mr. Sai Karthik, clear?
Yes, sir.
Yeah, do it. Yes, brothers, what you understand this question, you can ask. So what they're asking, a rubber cord of length 10 centimeter is stretched up to 12 centimeter. So what is the change in length, everybody? By this time you can understand. What is the change in length?
2 centimeters.
Okay. And what is the area of cross section of a cord? 1 mm square, 1 millimeter square. Find the velocity of a missile whose mass is 5 gram, which is hit with this rubber cord. Okay. So velocity of this missile. So rubber cord Young's modulus is 5 into 10 power 8. So we all knows that, everybody. So whatever the rubber cord potential energy, the energy stored in the rubber cord, if it is released, that energy completely will be converting into what energy? Anybody? Yes, please. When it is changing shape, class and all you studied that, it will be completely converting into what energy? All of you.
Kinetic.
That is what. So whatever the rubber's potential energy, which is equals to kinetic energy. So now we all know kinetic energy equals to what is the formula? Half into mv square. So what is the structured rubber? What is the energy stored in that? Just now we studied. What is the formula? Structured rubber band. What is the energy formula? Half into
Stress into strain.
Strain into volume.
Volume.
If you equate it, you will get it. So both the sides, half of is there, half of will get cancelled. So what else is there? You tell me. So we all people knows that. Even instead of this stress and strain, together I can write something. Stress means Young's modulus into, Young's modulus into, I will write as a strain. So which is equals to, so there is another formula we have studied that. What is the formula? Anyone? Yes, please. So Young's modulus into strain, what we used to call strain square into volume, understanding, which is equals to 1 by 2, half is gone already, mv square. Any problem, Pradosh? Clear? So now we all knows that Young's modulus theory of what is the delta L? Delta strain means what? Delta L by L whole square into volume is equals to mv square. Am I right, everybody? Clear? Please
Yes, sir.
respond. That is what. Now you can go with the substitution, but substituting time, be very careful with the units. So Young's modulus. What is the Young's modulus value given? Check the question and tell me. What is the Young's modulus value?
5 into 10 to 9.
Next, delta L. Delta L, how much, Amma? Here first you write it. 12 minus 10, how much it is? 2 centimeter. So 2 centimeter means what? Meters, everything. 2 into
2
10
into
power
10 to
minus 2. Next, length. Length means original length, 10 centimeter, which is equals to what? 10 into 10 power minus 2. Am I right? Speak, guys. So, which is equals to what? 10 power minus 1. Okay, Pradosh, Rudreswa. So, 2 into 10 power minus 2 divided by 10 power minus 1 whole square into volume. Volume means what? Area into length. Area into length is equals to volume. So, what is the volume equals to? Area is 1 millimeter square into length is equals to original length, 10 centimeter. So, convert it. 1 millimeter square is equals to how many meter squares? You all should know by this time, which is equals to 10 to the power of minus 6 square meter. 10 to the power of minus 6 square meter into 10 into 1 centimeter equals to 10 power minus 2 meter. So, which is equals to 10 power minus 2, here minus 6 here, plus 1 minus 2, which is equals to 10 power minus 1 meter cube. So, which is equals to 10 power. Total answer how much? 10 power? Respond. 10 power minus 7. Okay, va? Understood, Amma? Please respond. Which is equals to
Yes, sir.
mass. Mass is 5 grams. So we all knows that 1 gram is equals to how many kilograms? Everybody, 10 power?
Minus 3.
Minus 3 kilograms. See, unit conversion is always having a greater importance. Anybody having any doubt, you can ask me. So now you can do it, everybody. So we can solve it. Now you can see how to solve. Both the sides 5, 5 is there. Can I get cancel 5, 5? Any problem? Everybody? Yes, please respond. So which is equals to 10 power 8, which is equals to what is there? 10 power 8. Next, what else? 10 power 8 into this one. 2 square means how much? 4. 2 square means how much, guys? 4 only, yeah?
4.
Yes. So 2 square means 4. Now, this one, 4 into 10 power minus 4 divided by 10 power whole square means minus 2 into 10 power minus 7, which is equals to 10 power minus 3 into v square. So this is what is remaining. So now you can get cancel whatever you have, you can do it. So now what will be having that, everybody? So check it, everybody. So I will make it 10 power 8, 10 power minus 4, 10 power minus 7. Try to get cancel everything. What will happen, everyone? 10 power 8 minus 4 and let it be. I will cancel minus 4 and minus 2 will get cancelled. I will get here minus 2. So now what is the remaining, Rudreswa? So 10 power 8, 10 power minus 2, 10 power minus 7, 10 power minus 9. Okay, va? Yes?
Yes.
Yes, which is equals to 10 power minus 3 into v square. So now 10 power minus 3 will come this side. This will become 10 power minus 1. 10 power minus 3 will come this side. 10 power 3, which is equals to v square. So now 10 power v square means how much it will come? Anybody? Somewhere we are doing calculations mistake means let me know. Everyone. Anywhere mistake calculations? Yes, please. Yes, Pradosh. Check it answer. Anywhere mistake means you can tell me. This is 10 square will come. So 10 square means wrong answer. No.
Sir, 10 power minus 3 will come division, sir.
Yes, Laksha. 10 power minus 3 means 1 by 10 power 3. 1 by 10 power 3
4
will come this side, it will become 10 power 3 only. Yeah. Understood? Okay. So, okay. Then you can see that we will solve this one. So, this one, I will write it as usual. I won't take it as a 10 power minus 1. So, I'll write 10 into 10 power minus 2. Now we can get the answer. So, slowly you solve.
Sir.
Yeah. 4 we missed it. Am I right? Correct? Yes, Ra?
Yes, sir.
Yeah. So 5 will get cancelled. Now it will become, see everybody. So 10 power minus 1. So now I'll make it 10 power minus 2, 10 power minus 1 get cancelled. So 10 power minus 1 minus 1 is remaining. So I'll write it everybody. See that 10 power 8 into 2 square means 4. Clear? 4 into 10 power minus 1 whole square into 10 power minus 7, which is equals to 10 power minus 3 into v square. Now 4 I will put separately. 10 power 8 into this one 10 power minus 2 into 10 power minus 7, which is equals to 10 power minus 3 into v square. Now 10 power 8 minus 2 minus 7 means minus 9. So which is equals to 10 power minus 1 into 4, which is equals to 10 power minus 3 into v square. Is it okay, Laksha? Understand? Now you can
Yes,
see
sir.
that. So 10 power minus 1 and 10 power minus 3, both are opposite sides. So get cancel here, minus 2 will be there. So 4 into, nothing is there here. So 10 power minus 2 into v square. 10 power minus 2 means what? 1 by 10 square only. Correct? So 1 by 10 square will come this side. What will become, everybody? 4 into 10 square. Correct, ma? Everyone understand now? Please respond. So that is what it will happen. So 4 into 10 square. 4 into 10 square means how much, Ra? Which is equals to 400. So 400 is equals to v square. So v square is equals to 400. V is equals to root over 400. What is the answer? 20 meter per second. So that is the velocity. So what is the correct option? Option number B. Solve it, everybody. Anything doubt in this question, you can ask me. I will explain. Mr. Narayan, anything doubt? Pradosh, you can ask. Do it. Understand?
Yes, sir.
Girls, yeah. Do it. Mr. Murali is solving. Pradeep,
Sir.
anything doubt, you can ask me, Amma. If you complete this question, we'll go with that. Here. Now, same question you can solve in another way. Anybody can try. I will give you the clue also. With the help of the formula, what is this formula? You can solve that. Try it and we will do it. Okay. So now what is the method you can solve it? Let us see that now. So if you observe very carefully, this question we can solve without this much big process. There is a shortcut method. So how to solve this one? You all can see. So we all knows that another formula for that one. So let me write the given data first. You all can notice it, everybody. So delta L, what is the delta L is equals to 12 minus 10, which is equals to how many centimeter? 2 centimeter. Now M is equals to how many grams, everybody? 5 grams. And Young's modulus is equals to 5 into 10 power 8. And force F is equals to Young's modulus into A into delta L divided by L. So now you can see, guys, First, I will find it. Area is given like this 1 mm square, which is equals to 1 into 10 power minus 6 square meter. Do it, everybody. So I'll find the force. So which is equals to energy stored. Directly I can find it. Understanding? So now another formula. So what is the energy stored in that, everybody? Energy stored is equals to what? Half into F into delta L. Am I right? Speak, guys. So which is equals to what? Delta L square, which is equals to what? Half into mv square. Is it right, Amma? Please respond.
Yes, sir.
So that's all it is. So F is equals, I'll calculate now. Young's modulus is 5 into 10 power 8 into A. Area is how much? 10 power minus 6 into delta L 2. So 2 into 10 power minus 2 divided by length. Length is 10. So 10 into 10 power minus 2. So 10 into 10 power minus 2 means both will get cancelled. Minus 2 minus 2. So as it is. So they will get cancel it. Now next 2 ones are 2 5s are. Next 5 and 5 will get cancelled. So what is the force remaining? Verify it, everybody. 10 power 8 into 10 power minus 6. So which is equals to 10 power. What is the force, Ra?
2, sir.
10 power 2. So now stored potential energy is equals to half kinetic energy. That is what mv square. So I will directly substitute it. Half into force is how much? 10 power 2 into delta L value. Delta L value how much, Ra? 2 into 10 power minus 2. Am I right? Yes, please respond.
Yes, sir.
Everybody clear? So that is what it is. So now you can get the answer is very easily. Or else you can substitute even the velocity, which is equals to kinetic energy. So half into 5 into what is the mass? 5 into 10 power minus 3 mass, understanding, into v square. So you can equate this, you'll get the answers. So what is the velocity square? You can check it, everybody. All of you do it. So you can solve it. So finally we'll get answer. So both the sides you can get cancelled. Half and half will get cancelled. So we'll get velocity square is equals to 2 into 10 power 3 divided by 5. So if you solve this one, V is equals to, everybody, 20 meter per second will come. Everybody try it, all of you. Do it fast. And here we did one mistake. Have you noticed it? F into delta L or delta L square. I have done mistake here, but you not noticed it. Delta L or delta L square. Verify the formula. What is the formula we have done? F into delta L only, correct? Because F means one delta L is already coming. So F into delta L, not delta L square. Correct, Rudreswa? Are you there, everybody? So that is what is the mistake we are doing. So here not F into delta L, not delta L square. So here square won't be coming. So now you try to cancel out, everybody. That's why when we write a formula mistake, everything will be leads to the mistake only. So you have to be careful. So now what is there? You can get cancelled. So now you can see 10 power 2 and 10 power minus 2 get cancelled. What else next? Directly we have 5 into 10 power 3. You can check it, V square. So 10 power minus 3 will come this side, 10 power 3. 5 will come this side, division, 2 is here. So 2 into 10 power 3 divided by 5. So now you can make it 2 into 10 power 3 means what? 1000. So 2000 divided by 5. So what is the 2000 divided by 5, which is equals to 400. So V is equals to root over 400, which is equals to how much answer? All of you, 20 meter per second. So note it that formula, all of you. So we all knows here F into delta L, because F means what? Young's modulus into A into delta L divided by L. So you should not miss that. Instead of, if you write delta L square, everything will be collapsing. So that's why I'm just insisting you. So make it very careful. Formulas, if you know, we can solve the numericals always. It's very easy. NEET and JEE mains. I'm not talking about advanced. JEE mains, always a conceptual based questions only. If you are good in concepts, means in the sense of, if you understand the question and if you are able to get the formula, 100% you'll get the mark. That is what you have to remember. Okay, everybody? Clear? So application oriented questions only they will ask in JEE advanced. Even advanced sums also sometimes will be very, for that also formula is very necessary. So but JEE mains and NEET, always how good your concept only important. So the what method you are using never bothers, because it's all full of MCQs. So you have to be very fast calculations, And formula, always remember you have to make error free. If you make it error free, 100% you can make it. That's all it is all. So this is all about this energy stored in a structured one. If anybody is having any doubt, you can ask me, or else we'll proceed with the last concept of this chapter. So there is a few concepts. That concepts we'll discuss in thermodynamics studying time. We'll continue that and all. So no need to worry about it. So now we are going to study the next concept is the last concept of this chapter. That is what thermal stress and strain, and as well as Poisson's ratio. So these are the concepts we are going to see now. So all of you keep heading. Thermal stress and strain, Poisson's ratios. Poisson's ratio. So this is also very important concept for JEE and as well as NEET. So you can focus on it and you can learn it. So it's also very important and very interesting topic also. So now let us see that. So what will happen? Thermal stresses and thermal strain. So what is this thermal stress and what is the thermal strain? So we'll discuss now. So first we'll discuss a thermal stress and as well as thermal strain. So now for example, first I want to say you two systems. One is free to deform in any direction. That is the first system. So I'm taking a rod, for example. The ends of the rod is not attached to the anything. Means in the sense of the free ends are present. It can extend this side also. It can extend this side also when we are heating. So that is what we used to call it as a free to deform in direction, any direction. A rod free to deform. Deform means change its length, size in any direction. So that is the rod we used to call it as a free to deform in any direction. Now, let me take this rod length is L. Now, if I keep on heating is keep on increasing. So definitely if it is a rod, it will show something property. Can anybody tell what is the property it will show? If it is heating, what will happen to the object? Anybody? What will happen to the object? It will start expanding. Am I right or wrong? We have studied already. Everybody?
Yes, sir.
So if you are keep on heating, the rod will start expand. So that is what, let me take as it is a free to deform any direction. So the length of the rod is increased because of heating. So we all know if you want to deform the shape of any kind of metal, we have to we have to heat it only. So now the length of the rod become L plus delta L. This is what is the length of the rod because of heating. So now, what is this delta L? For example, if you want to find it, how much length it is changed from the original length? That is what delta L is equals to, please note it, length into alpha, not it is proportionality constant. What is the symbol? Call it as a alpha into change in temperature. This is the formula for calculating delta L, change in length. So what is this alpha? Alpha indicating thermal coefficient of, it is a what expansion? Linear expansion or aerial expansion? What type of expansion it is? Linear expansion. Okay. So volume expansion, linear expansion, like that will be there. So length is changing. So what is that expansion? We used to call it as, everybody? Linear expansion. Okay, ma? All of you? So now, what is this alpha? That is very important. Means, for example, if I increase the temperature 1 degree Celsius, remember that 1 degree Celsius, if I rise the temperature, then how much length is increasing of 1 meter rod? That is what? Length increased in 1 meter rod for how much degree temperature? For how much degree temperature, everybody? For 1 degree rise in temperature. Means the either increase or decrease, doesn't matter. Either increase or decrease, the length increased or decreased in 1 meter of rod for 1 degree rise in temperature. That is what we used to call it as alpha. Alpha means, remember, change in length either increased or decreased per 1 degree change in temperature per unit length. That is what we used to call it as a alpha. Alpha means change in length increased or decreased per 1 degree rise in temperature per unit length. That is what we used to call it as a alpha. I hope you all clear. So for 1 degree rise in temperature, how much length is increased or decreased in a 1 meter rod? That is what we used to call it as a thermal coefficient of linear expansion, which is called it as a alpha. So anybody remember, this is only for when the rod is free to deform in any direction. This is what is the formula for calculating the change in length. So all of you remember that. Now,